I feel that yesterday we had a broad perspective of one particular national scheme, and we got some insights into that. Now, that is not the only scheme available for researchers. There are so many schemes available. Okay, but that's being a biggest scheme by the government of India. We concentrated much on that and how the paradigm is shifting towards industry and industrial research. Now, today, as Dr. Nag told, mostly we'll be talking about how to evolve a good proposal and what are the elements that we need to concentrate and how to self evaluate the proposal before submission, and those are the things that we will be concentrating. Okay, I think we can get into the first slide. So this is the type of a framework, the R&D proposal framework. It finds out some of the core elements that any proposal, R&D proposal, will look like or should be incorporated. Now, there are 2-3 slides on this. I will be concentrating on each and every element of these, the framework. First and foremost thing, see, we are all researchers. We had a good education and good institutes, spent a lot of time, maybe MSc or BTech or MTech, and then PhDs. And by choice, we selected, as a faculty or as a researcher. This is our choice. Otherwise, simple graduation could have faced, so many other jobs. But by choice and passion, we picked up this line. And this is a continuous, knowledge updation. This field requires that, and a commitment and passionation. We need to be passionate about what we are doing, and we are self-motivated people, and that's what I expect. So when I say a researcher, fundamentally we are looking at a motivated individual, self-motivated individual. He doesn't care for the recognition or appreciation from anybody. He satisfies himself what he is doing. They're good or bad, he is experimenting, he is spending the time and energy and developing, or creating the new knowledge. Okay, so these are the motivations that an individual gets by doing research. So motivation is the fundamental building block for a researcher, and he should be passionate about it, whatever he is doing, either chemistry or history or geography or mechanical or civil or electrical, whatever it may be. So he should be passionate about, and in fact, we are passionate about what we are doing, and there should be a commitment. So the sustenance and as well as commitment is very essential. There are certain field of research where you may not get any type of a immediate recognition, but in the long run, every field, every research subject, every subject will have the recognition. Somewhere it will go and fit in. Okay. For example, the Boolean algebra 150, 200 years back, when it was developed, nobody appreciated it. What for? 0 and 1. Who will use it? How it will be applied in the the real world? So at that time, everybody ridiculed him. Friends, you can see what type of the developments that particular thing happened when the digital systems are getting evolved. So that committed research is very much essential. Also, we look at the personalities of a researcher. Fundamentally, their risk-taking ability is very high. They want to explore the unexplored areas. They want to experiment it. They want to know why it's happening like this. The curiosity, and then they will go for the challenges. Whatever the challenges that comes across, they will overcome it. Okay, and that is the type of a overall scenario for a researcher. I hope every one of us, we are having those commitments. Now, In this respect, what I can see is there are low hanging fruits. Some people will try for it, some people try for the shortcuts. In the nowadays of Chat GPT, generating a proposal is not a big thing. Okay, you know, those things normally will flat. Okay, and people will come to know what it is, and we will be ridiculed unless otherwise the core strength in research and commitment is not there in the proposals. Normally it will be identified because there is various levels of scrutiny, various levels of presentations, and there is a public discourse and discussions with all the eminent scientists of that particular field, so that the things will be identified. Now, the core researcher sitting somewhere in the corner of the country, in the corner of a lab, he will continuously doing his research and maybe publishing or patenting or nurturing the industry. His name, unknowingly, it will be plop up everywhere in the country. That's what I observed. He may not be knowing, but his work speaks for himself. Okay. And the shortcuts like incremental research is not going to fetch. Let us be very clear on that. Okay. Now somebody applies some image processing and fuzzy logic on a particular application like medical imaging, and algorithm is fixed, and all the learning algorithms are developed, and then somebody will pick it up and apply under agriculture. So if you look at it, everything is combined, and then experiment is repeated in a different field. So the experts will come to know. So be clear on that. We may think that it's a very good proposal. Why it is got rejected? Nobody has done this type of work. Nobody done in agriculture. I have done it. Why my proposal got rejected? These are the frustrations. Normally it comes up. Okay. No, I'm not talking about the system bias. I'm talking about the proposals. The experts will identify. Well, this is the fundamental things which I would like to cover. That there should be a commitment. One should be passionate, and you should have a committed research agenda and risk-taking ability, and the challenge to explore the unexplored. Okay, and as well as get into what you call the experimentational aspects. Well, these are the basic requirements. Now, we know we have done a lot of everyone, most of them maybe have done your PhDs. So, how you started your PhD? You have worked with your guide, pick up a topic which is of your interest or your guide's interest, and then start exploring. PhD is an earned degree. That means you are going to create a new knowledge. All other are academic. There is a test books, you are read, and there is an examination, you pass it, and you get a degree. But PhD is not like that. You are creating a new knowledge. Most of the cases, I'm not generalizing. So that new knowledge creation is the fundamental of any R&D proposal. Okay, so based on your background and interest and your passion, you are passionate about any one particular field of research, you have to pick up a good research theme. Maybe in the continuation of your PhD or your postdoc research, or you might have come across some other related field which you feel now I should pursue. Okay, that type of a research theme you have to pick up. Yesterday we have seen so many themes and subsectors. Okay, each subsector is a huge a plethora of research topics. Okay, now there is no dearth of research topics, and it's industrial applications. Therefore, selecting the theme is very crucial. And in that, you need to identify a suitable topic. Not that entire theme you can handle. There are so many aspects that into this. Therefore, normally an R&D proposal is for a duration of 3 years. Normally, there may be 1 year, 2 years proposals also. I'm not ruling. Generalized, it is 3 years duration. So in a 3 years limited duration, what you can achieve, that needs to be identified. That is, selecting the topic is very, very, very crucial. Now, once you have identified, a type of a theme and topic, then most of the people fumble in creating a title for the proposal itself. The moment you look at the title, we can say it's a, no need to go through the entire thing, that type of feeling you will get it. Okay. For example, if you give a, I'm talking in the perspective of, my experiences in DST. So we used to give a call for proposals. Okay, let us say GIS and remote sensing. That is the broad theme. Now, when we gave this call for proposals, we received a lot of, these are tons of, the proposals we used to get. In fact, from Lodi Road, we used to get a lorry to dump the proposals, when that was a, hard copy proposal. Each copy needs to be submitted in 20 copies. You can imagine how much effort you people might have put, and how much, the postal department put, and how much efforts we have to put to scrutinize all these things. Now, look at the topic of this, title of these proposals: GIS and remote sensing for health issues in Maharashtra or Madhya Pradesh. Then we thought that they are going to, map all the hospitals, roads, and primary health centers, and then, headquarters hospitals, and entire, they are going to map it onto the GIS, and they will also identify some of the human clusters, so that we will have develop a type of a geospatial based analytics engine for administrators to use in case of any, or they want to create a new hospital which is the, a type of a good location. We thought that no, entire things about entirely different things. The title is GIS for Maharashtra or, Madhya Pradesh or Rajasthan, wherever, which I'm just taking a names, but it could be anything, Tamil Nadu, Andhra, or Karnataka, whatever it is. Now tell me, in 3 years, with a minimal funding of 30-40 lakhs, you will be able to develop all these things? Number one, physically not possible. Can you map all these things? No. Are you going to collect the secondary sources of data and geolocate onto the map? It's not possible. Whether your approach is correct? No. The title is very vague. Now, when I moved to the big data initiatives, now again we gave a call for proposal. The same PI, the same institute, now submitting a proposal saying that the big data analytics for, health issues in XYZ state. Internally, everything is same, only title change. Fortunately, we have elephantine memory. The moment we look at it, we remember, the proposal, we remember the PI, we remember the institute. So even if it is thousands of proposals, somehow we have that ability. Not only me, the other, DST colleagues. देखो GIS में ये big data में आ गया. Then I went to cyber physical systems. Then the same proposal with cyber physical system for health issues in so and so XYZ state. Internally, everything is same. मैं बता रहा हूँ, you might have put lot of efforts. You might have run around in the institute taking principal signatures or HOD signature and, commitment from the institute, then preparing, 20 copies, whatever, not. Your effort should culminate into a approval. When that content is important, what you are writing in the proposal is more important than your efforts. So we are going to concentrate on that. The first thing is the title itself. Okay, then we need to have a very brief 5 to 10 lines, a type of an executive summary. Any layman can read, understand what this proposal, this 30 pages, 40 pages proposal is going to do. A type of a nutshell. It should say what it is and what it is going to do, and then what is its impact. Okay, and it's not very high scientific terminologies. Even an economic student study that executive summary should be able to understand, pure layman's language. Okay, now that executive summary is for anyone who is not having any scientific background. They should be able to understand, because this proposals goes to the finance, it goes to the administration, it goes to the various economists. They are not scientists. So they look at it sometimes. Okay, so that should be very clear and crisp. Okay, now the third aspect is we need to have a proper introduction. Again, it should be in a very rudimentary, very plain language, what it is, why it is, and how you are introducing the proposal to a person called an administrator sitting somewhere who is going to approve the proposal. Okay, that should be introduction. And the importance of the research and why it should be done. If you don't do it, what will happen? I mean, all these things somewhere, very lucidly, it should be, introduction mein thoda sa, it should be better than executive summary in terms of scientific wordings. Okay, their executive summary is purely for the type of finance people or administrators. Introduction should be for a semi-scientist type of people who are scientific managers who will be able to understand. Okay, now important point here, I would like to spend some time on objectives. Friends, my experience, most of the cases, people write 3 pages of objectives. It doesn't work. They will put lot of scientific jugglery into that objectives. They will put a lot of equations into the into the objectives itself, and it's very difficult to understand what this project is going to achieve, unless otherwise you spend huge amount of time and it runs for 1 or 2 pages objectives itself, then that is not going to cut the ice. Okay, what I suggest is my suggestion, I may be wrong also, you can take it as an advisory. Objectives should be very clear and crisp. In most of the cases for a 3-year project, maybe 2 or 3 objectives. This project is going to achieve, and then whatever it is. Or this is to experiment and develop a process and procedures to achieve so and so. So these objectives should be very clear. It should be, civil, or it should be, history, to identify, to develop, to experiment. These are the some of the things that should be incorporated. Okay, and objective should be very clear, crisp, and not more than 2 or 3 broader objectives which can be achieved within the duration of a 3 years duration. Okay, so when you are writing the objectives, we have to consider what are your constraints. Like you may not have any required equipment, or you may not have the time to do the type of experiments, or infrastructure may be in some other institute. You may have to travel there and access the equipment, or you may have to work with some other co-PA who is sitting somewhere else, or you may have to work with some other industry. Those constraints, everything has to be properly understood, and objectives has to be achievable, objectives has to be clearly stated. Okay, and this is very crucial. You take any project and just flip the page, go to the objectives, you will come to know, yeah, this is to be put left side or right side. That is the type of binary decisions people do take when looking at the object. Because when we are not able to codify and bring out the clear objectives, then how the research and then our rest of the proposal will be, probably it gives an indication. I am not telling that everywhere it happens, but most of the cases, yes, that is what. Once we have fixed the objectives, of course, you might have done, the what you call, analysis and a survey before getting into all these things. So here, what needs to be done is one should concentrate on gap identification. You picked up some topic and you have certain objectives. Okay. Now, in that topic and to achieve that objectives, whether it is already done or some work is going on, or who are the labs, which are the institutes, or who are the people, both at international and national level, a type of a 360-degree analysis is required. I'm not generalizing, it may not be applicable to some subjects or some topics, but mostly a type of a analysis needs to be done. Okay, so once you have that global perspective by analyzing the international scenario, you get an idea. Okay, oh, this is the global standards in this particular topic or in this methodology process. Then you analyze what's happening in the national level. Okay, then you will find the gaps. There will be some gaps, I am sure. In any field you take it, there will be gaps. Or we may be better, or international may be less. I'm not telling always vice versa. In some of the fields, we are far, far ahead of rest of the world. Okay, so there is a gap. Identify those gaps. Okay, now that gap identification is very, very, very crucial. Otherwise, what happens? Like yesterday, what we have seen, the rudimentary proposals, incremental research. These are the words they attach to your proposal and throw on the left side. Okay, now that means you are serious about your topic and you have done some homework. You analyzed what's happening in the international scenario. You identified the labs where this type of work is going on. You also analyzed and some of their research papers, and you also analyzed, interacted with some of the people. In every case, it may not be possible. In some cases, you attended some of the conferences. You know what work is going on, and national level also you analyzed. Now, finally, after analyzing all these things, identified a huge gap or a small gap, or there may be fault in the process itself or procedures itself, or a combination of all these things. Now you identify the gap. Now that comes to the meaty part, the methodology. Now you have a lot of experimentations has to be done. You have to do a lot of data analysis. Then you have to develop a new process or a procedures. Okay, that is variable from subject to subject, topic to topic. For example, there may be theoretical physicist or experimental physicist. Okay, so that type of micro level details I will not be able to give you, but fundamentally based on your topic and your objectives, the methodology should clearly bring how this particular research is going to fill that identified gap. Okay, what methodology people are using and what methodology you are going to adopt so that it is going to fetch better results than them. They might have failed, but why you will not fail, that you have to substantiate it. Okay, so the details about the meaty part, you put a lot of equations, you put a lot of graphs, you put a lot of whatever you feel that is required. It is a highly scientific content, the methodology part. Okay, and you substantiate saying that I have done some preliminary experiments in my lab theoretically, and I found these are the possible options available. Then if you pursue this particular field, I may get a good results because I have already done some preliminary work with the help of my students or my PhD scholars or with the other colleagues, whatever it is. That means you already carried out some preliminary work. Now to enhance that particular methodology or process, now you are seeking funds for the project. So generally what happens generally, I will tell you, it may not be applicable to everyone, and I'm not generalizing. The institutes, whenever there is a NIRF or NAC accreditation or NBA, those regulatory bodies come for inspection or these things, then generally all the faculty will be goaded to do some research, bring some projects, write some papers, file some patents. lot of pressure comes on to this. Now, when that kind of pressure here, you cannot concentrate on all these things. They're pushing the proposal is important. Our institute has pushed 200 proposals to the DST or MIT or this way or that way. That's it. The number is important. Content, nobody bothers. Yeah, the number is important. Okay. So, that type of things, everybody can understand what it leads to. That's why I said motivated, passionate, and committed research. Those people are different. Okay. So under pressure, I don't think, knowledge evolves. Now, that is a highly personalized thing. Research is highly personalized. Nobody gives any, appreciation. He is working for himself, for his satisfaction. That's it. Of course, once you have done research, the positions will come, you'll become dean, you'll become, director or principal, then VC, pro VC, all those things will follow. That is different case. But the fundamental, you need to have that motivated and passionate. So the methodology part, that's where you have to show your complete the scientific, knowledge and methodologies. This is very, very, very crucial. Once you cross the bridge of objectives and gap identification, now the person who is reading the proposal will get to know, it looks like very serious fellow. Okay, now he has done some analysis. He has brought some data on international level. And he also analyzed, national level data also he brought it. And, he identified, some gap areas. Then he is motivated to get into methodology. So even whoever is reading the proposal, he will be motivated to get into the details of methodology. Now, here, you people have to keep one thing in the mind, You may be a good researcher in our chemistry. You are a best faculty in our university or in an institute. Okay, students appreciate you. The teaching is one thing and research is another thing. Let us have that. Good teachers may not be a good researcher, or good researchers may not be good teachers. And having both the things in one place is a beautiful thing that one should expect. Okay. At the same time, good researcher or scientists are very bad administrators. That is also there. Again, I'm not generalizing most of the cases. Okay. Now, when the methodology part is properly, written, and it's not the volume of the proposal that you should, look at it. I have developed a 100-page, project. No, doesn't matter. And with all these things, you can have a 5-page proposal. Let me tell you, if you properly the English word and the condensation is properly done, and proper scientific material is brought in, I don't think any proposal can be more than 5 to 10 pages. That itself is more. In one page, you can summarize the entire thing. Now, this methodology part mainly meant for subject experts. You are experts, no doubt. You have done a lot of research in this particular field. When you people submit the proposals, we at the governmental system, normally we take the experts' views on the project. So we send this proposal to the subject experts. We have our own method of identifying who is the people and where they are there. All those things are there. Okay. Now these proposals are sent to at least 4 to 5 people across the country, and sometimes no, it will not go abroad. It is only within the 4 walls of India. Okay. Now remember, these people spend 20-30 years of their career in research in that particular domain or in that particular subject. Okay. The moment they see whatever you have done, the 360-degree analysis, international, national, and all gap areas, they may be knowing in fingertips whether you are rightly identified the gap or the methodology you are going to adopt is going to fetch the results, or again it is going to be a failure experiment. I mean, No, even failure of experiment is not wrong. There is nothing wrong in that. But it should not be, by rule, because everybody failed, so I also failed. That cannot be the answer. So those experts will analyze within no time and they will give you a type of a rating on the proposal. Okay, so this we have to keep in mind. Okay, maybe executive summary is for the normal man. Introduction may be for a semi-scientist. Gap identification also they may or may not understand because you are analyzing both the things. But the subject experts will definitely understand both gap analysis and the methodology you are going to adopt to do this particular project. And they will also analyze whether the 3 year duration is sufficient, whether what budget you are asking is required, or the equipment what you are asking is related to this proposal, all this particular research, everything they will give the opinion. Okay, so keep that in mind while writing proposals. Okay.
Do we need to write objectives before gap identification itself, or gap identification followed by objectives?
No, see, I just put a sequence. Okay. Once you have done all these things, then finally you arrive at the objectives. Okay. You identified the methodology, you identified the gap. See, this is a type of a sequencing for my presentation. What methodology you adopt, you adopt. Okay. Or you may talk with the industry, identify their problems, and then you keep as an objective. So which one is first, which one is the last, that is left to you people. Okay. Generally, after identifying the gap, the objectives are set.
Sir, if it is a completely new idea which is not existing in the world, then how we have to approach?
Yeah, then you can always say that why this new idea is going to change दुनिया को इधर उधर कर देगी, बताना पड़ेगा आपको.
Okay.
Yeah. So that's what I told you. Boolean algebra, when it came, nobody bothered about it.
Mhm.
Okay.
No, if you're going to discuss with someone else, it will not going to be leaked with other people's.
No. There are people, the moment you come out with an altogether a new idea, definitely it will be appreciated, let me tell you, in the expert committee meetings.
Oh.
We have done. Oh, let us move into the next slide. So, another major stumbling block for the researcher is how to budget the proposal. Okay. Now, generally, the budget proposal for a 3 years project, so major components are, what is the project staff, what is the equipment, what is the miscellaneous cost, what are the contingencies, what are the travel costs, and then overheads. These are the major. There may be other things also. Okay. Generally, these are the identified budget heads they call it as, or object heads. Okay. Now, again, it will vary from subject to subject. Okay. But generally, science and engineering, we can put them into one category. And humanities and other things, maybe we can have a different category, not for any other reason, because things like equipment and other things will be very minimal in those cases. But science and engineering, yes, it is all equipment driven. Okay, so that way you try to understand. I will try to generalize as much as possible. Now, the fundamental thing people do is you have a 3 years project, and you are a PhD, you are a assistant professor, or beyond that, and you have done some good research, published some papers. Okay, now they should look at taking JRFs, junior research fellows, to build in the project proposal itself. Okay. But there are other people who are non-PhDs or thing. I'm not differentiating, but generally, those who are having some good research background should take the JRFs. So JRF itself is costing around 20-24 lakhs per year. Isn't it? 12 lakhs per year. Am I correct? Yeah. So, why it is required is you are having a good lab setup and you yourself is a good researcher. By taking a JRF and he will register for a PhD, and JRF fellowship is coming and built in the project itself. Okay, so he will register for a PhD. At least you are assured of next 3 to 4 years of his studentship. And also, the government looks at it by giving a project. We are enhancing the human resources. We are enhancing the R&D capabilities of a researcher, and also to some extent, enhancing the R&D infrastructure of the institute. So that's how it will be looked at it. The public money is going for the betterment of the society. Okay. Now, so you have to see if the project is, broad theme and you want to complete it within 3 years, then probably you can go for 2 JRFs. Okay. And most of the cases, what I have seen is they will ask for, research assistant. What will happen to research assistant after 2 or 3 years? At least, this fellow will get a PhD. Okay. No, I'm not telling you anything, this you have to do or that you have to do. I'm just giving you the overall perspective. Okay. If a student or an MTech student spends in your institute for 3 years, at least you should have a hope that he will get a PhD by part of this work. And moreover, by being, a PhD scholar, he will help your research. So it's a win-win situation for both the people. That's what exactly the Tier 1 institute does. Because a faculty who is PhD in a good institute and has done his postdoc, went abroad and all those things, and joins as assistant professor in Tier 1 institute, first and foremost thing is he has that capability of writing as I told, 5-6 pages good proposal. He can convince anyone. He can write all the buzzwords, in that field, and he will get a project. What he fundamentally does is he recruits, 2 JRFs, put them onto the topic. There is a good equipment available. There is a institutional grants also available for equipment. Okay, and put the JRFs, and there are BTech students. Their projects are being done on that. So what happens is he get good working hands to support his project, because PhD topic and his project objectives are almost more or less same. So he gives it to them, he guides them, he monitors that, and then he writes another proposal for another department. This is a cycle that goes. One, he creates his own R&D infrastructure, his own labs. He creates his own group of PhD students, and he is teaching. Therefore, the inflow of BTech and MTech students are coming up. It's a plethora of human resources and equipment provides them that kind of freedom to explore into more areas and getting more projects. So I will leave it to you people whether you have that kind of ecosystem in your institutes. Okay, that's about the project staff. Okay, you have to be very careful. You have to defend it. You have to substantiate it. You can ask 5 JRFs, but you may have to substantiate it. That's all. No, I'm telling. Then coming to the equipment, I have seen in computer science, they want to develop some algorithms. Okay, and they want to experiment some learning technique. They will ask some cluster of computers. Project cost is 1 crore, almost 80 lakhs they will ask for the cluster of computers. When you ask, you are from engineering college, you have a full-fledged computer science department, you are admitting some 2,000, 3,000 students. Now tell me, without this kind of a cluster, how you are teaching? How the students are getting exposed to the softwares or hardware or graphic units, how you are doing it. then they will keep quiet. Okay. Now, that type of embarrassing situation, let us not. You have to be very objective in projecting the equipment. In chemistry or in physics or in some cases, you may be having a good equipment already inbuilt in your institute. In addition, for this existing equipment, you may require some software, or you may require some additional sensors, or you require enhancement of some equipment with additional features. Those things are quite possible. And every project comes with a new requirement. I need XRD, I need this TEM, I need that. These are all very costly equipments. So institute should not look, these government funding proposals for, enhancing, procuring the advanced equipment. But the problem comes to the PI, who is go and stand in front of the committee and start defending his requirement for the equipment. It's a very pathetic situation. So you people have to be very clear for this objectives, for this methodology, what kind of equipment I have already in the institute or in the surrounding places. And in addition to that, you require some things. So generally you keep the equipment somewhere around 15 to 20%. Again, it's not a thumb rule, it varies to vary. You may be doing like somebody is talking about a new idea, altogether. It may require, different kind of equipment, it can kind of a different, sensors. In that case, if you are able to defend in front of the expert committee, then government doesn't have any problem. So be clear on those lines. Okay. So in some of the humanities and science, for example, mathematics, what is required for a mathematician? He will say, I need some 4 computers. What for? No. This algorithm I am developing, I want to experiment it. Why? Even your iPhones, even small, computers, even age-old computers also can, this thing. No, I need a very fast computer so that I want to do my testing, very fast. I don't know what fast, you're talking. No, I'm just taking an example, madam. I'm talking about even humanities also. Every project, invariably they will build computers, laptops. Some people asking about iPhones. Some people asking about, पता नहीं क्या क्या चाहिए उनको. ये blatant exploitation of the system. Okay, so which is very much essential for your project to complete it. You identify the minimal equipments. Okay, that have to be. Then comes, some people will ask about miscellaneous and contingencies. No, see, everything you cannot foresee in the project, writing stage. Once you get a project, there are so many things. Some connectors are required, some, some adhesives are required, or some, chemicals are required. Something, which is unexpected, which is all required. Some plug is gone, So those things, So those things has to be inbuilt into the miscellaneous, and that means we are not foreseen, the requirement of those things. Something has to be built. Contingencies, similar things. Okay, suddenly something erupted, or some printer, that a drum got spoiled. So it is not expected. It was working fine, but when I'm doing all these things, the drum got, then you may say, over 2,000 rupees I will spend from contingencies, get it repaired actually, but you have to differentiate. So it will be in that lines. But people put, almost 30% of the cost in miscellaneous and another, 15% in contingencies. No. It cannot be that way. So look at those things. These are all very. See, the government looks at the project in a holistic way. Okay, not that everything is inbuilt in the project itself. They say that there are certain things which cannot be foreseen. Those things also has to be catered. Then comes to the important thing, travel. In the travel, there are 2 kinds. One is if the project requires field level survey or experiments or accessing of equipment from other institutes, You may be in Bangalore, equipment may be, let us say, in IAS in Bangalore itself. They are ready to share the equipment, but you have to travel from one corner to other travel, there is a travel involved. Okay, those type of things also it will be. Or the equipment may be in Mangalore. So Bangalore to Mangalore, you have to go and access the, stay there and then conduct the experiment and come back. So this is called, we call it as a field travel. And some humanity subjects, they may go and survey, some of the areas, they interact with the people, collect the data and come back. In GIS, for example, ground truthing, they has to be done, they have to go to the field. So these are all called field survey in a broader term. The other component in this travel is when a project is sanctioned, every 6 months, you have the monitoring committee. Okay, either you will be called and asked to submit the progress of the proposal. Normally, it will happen in some academic institute, either in Delhi or in somewhere, they will identify a location. Then there is a travel involved. You have to go and make a presentation and come back. Okay, so there is a travel. So those are all, part of the travel. Okay, and some people say that I want to go to abroad, to do some experiment. It's not allowed actually. Okay, unless otherwise it is a collaborative project. Then comes, overheads. Normally it is 5% of the total budget cost. With overheads, it goes to the institute, and that's how the entire budget is, rationalized. Okay, and remember that once you apply for 100 rupees project, finally it may come all, corners cut, maybe 60 or 70 rupees. So don't think that, in that case, I will enhance the budget to 130. Then you will become a joker there in front of them because you will not be able to substantiate. Okay. So in some cases, there is no cut-off budget because you are tightly written the proposal with a clear of everything, and you yourself, rationalize the budget and you say that this is the absolute minimal requirement. Okay. And also, one more suggestion I would like to give in this. Most of the institutes are private institutes. Public funded institutes, that is different. They will get a government budget and other things. Particularly, the private institutes, they need to spend some time on this project. Unless otherwise their skin is involved in this project, they are not going to own it up. Okay. Not only that, okay, how you make their commitments properly. That means when you say equipment cost is 40 lakhs, then your institute gives a certificate saying that we will contribute, let us say, 20 lakhs. If government gives 20 lakhs, we will give you 20 lakhs. Okay. That commitment has to be there. Almost 25% of the total project cost, including the faculty time, lab time, energy, then water, and including all those things combined together. Plus, in by liquid cash, they should contribute this much. If it is the return in these things, yes, I require these 40 lakhs equipment for this experiment. Okay, I'm not asking everything from you. I'm asking 20 lakhs from you. 20 lakhs, my institute will put it. So then you will get a chance. Okay, the institute is supporting this. Okay, and that simple, it is not a letter stating that we will contribute. It is by deed. That means when you open a sub account for this project, the physically money has to be transferred to that account and UCSC has to be submitted for the entire amount. Normally, what happens now? People give a certificate saying that, oh, okay, no problem, we will contribute 20. When the project goes, nobody bothers. Okay, and when UCSC comes, whatever money released by the government, that much only UCSC comes. So they made it as a compulsory that your commitment of 25% has to be put into the project cost and in the account. Then UCSC has to come to from entire amount. That means if 100 rupees is the project cost and 25% means 125 is the total cost, then you see a statement. And money cannot be, shifted here and there. So these are some of the hints I am giving. Okay. I think we spend enough time on this budget? A lot of people ask about in computer science projects, sir, nothing is there. If you don't ask computers, what will ask? There is nothing. No. I will tell you. You say that we have certain computational cluster. With the existing cluster, I will start my experiment and simulation or whatever, what algorithm testing or whatever it is. Okay. After 6 months or 1 year, based on the results what I am getting, then I may have to enhance the computational. I require enhanced computational power. So I explored the cloud access. I explored the other institutes, but it is practically not possible. Therefore, I would like to add 1 or 2 nodes into the existing system. You ask for the additionality of the 1 or 2 nodes, not the entire cluster. Or you ask for additional software or number of licenses. I mean, something. There is a better way of telling the same thing. You are asking the same thing, but there is a way of telling. Okay. In the phase 1, I will use the existing infrastructure. In phase 2, I will go for some additionality of the something like that. Okay. Now, expected outcomes. In the proposal, you have objectives, you have the methodology, you have the budget. Once the things are got sanctioned, we need to have a kind of outcomes of the project. What is that we are expecting from this project? That's why I put expected outcomes. That means it is expected. It may or may not come. Okay. At this stage, I'm expecting that something will come out. That could be in the form of, could be journal publications, or I may file a patent from the outcomes of the project, or I may write a book chapter, or I may attend some good conferences, or I may present my results into the good workshops. Okay. These are all possible outcomes. You are not giving any surety of all these things. Okay. By looking at your methodology, looking at your objectives, people understand what type of things can come out of this. Okay. But you have to quantify the possible expected outcomes. Okay. Now, also, wherever it is applicable, is it possible to start a startup because you are doing a good research and there is a lot of industrial applications are available, and there is a possibility that this technology could fetch a startup? Okay. Now, that is also you have to say. Everything cannot be basic and fundamental research. Okay. That is also should lead to type of solution to somewhere, someone. But applied research definitely should have kind of a industrial or startup possibility. I'm just telling possibility. Every project need not be, end up in a startup, not necessary. But wherever it is applicable, that has to be mentioned. Or you say that I am doing a very basic research. Okay, at this stage, I cannot give guarantee that it will lead to a startup. You can say that, no problem. But you are doing some applied research and say that, no, I don't know whether it will, where it will apply, who will take, which industry is going to take it, I am not aware. Then it will be a problem. And then you have not done your background properly or homework properly. Or this research may support or mentor to existing startups. Okay, generally startups are done by the students. There is no research background for them. Somewhere your research may help in enhancing the startup fellows. Okay, that entire mechanism of taking stake and then how to mentor it, those things, we will not get into all those things. Okay, here I would like to mention one thing. These startups, okay, students are doing, and then those who are entrepreneurship development things are happening and other things. A good researcher who is having a type of entrepreneurship abilities, I think they should start a startup. Why I'm telling is, I visited, during my stint in government, MIT I visited, Stanford also I visited. There, particularly advanced technology, people always look at very advanced fields because that's where they will have edge. Okay, they will not do the research for the purpose of research. Always they look at where it can be applied, how I can monetize it. That is their lookout. Almost most of the professors, they are mentoring some 10 to 15 startups. Their model is, first they do the research, lab is available, students are available, identify new innovation or a technology, patent it, and create a startup in his name. Then what happens? Then some entrepreneurs will come and pick a stake in that, and the mentor will withdraw and he will hold some 5 to 8% of the stakes. The rest of the things will be sold to the entrepreneur, and he will continue to mentor it. Then what happens? He is having his skin in the startup, and the startups will get beautiful research advisory from the professor, and everybody wins it. So those systems probably we may have to look into and if possible, incorporate it. But as of now, it is nothing is there. Always we talk about, okay, startups is meant for students. Those who want to do business, they will go for it. No, it will not sustain unless otherwise full backing of a research background. The startups is not, at least in some fields. In some other field, it may be okay. Okay, in deep tech particularly, they cannot sustain without research background. Then at least your research should feed into some industry, some component, either pollution control or the carbon sequestration, or recycling of water. Somewhere industry should have a type of a buy-in into your research. And sometimes you may give provide advisory to governments that this is things happening in this lake, these are the pollutants are coming. This is my research shows that if the trend continues, so maybe after 20 years the lake may die. Okay, this underwater depletion is happening, or there is a type of new insects are coming out. So some research which will come out. The government means what? Once things happens, then probably they will react. Before that, as a researcher, you are forewarning them. They may act, they may not act. That is different, but you have a duty to advise the governments that this is happening. What I mean to say that your research should fit somewhere into those holes. Okay. Then also your proposal at the end, you are doing a fundamental and basic research and as well as some experimentation in your lab. Once good results comes out, what are the scale up options? You want to scale it up. Okay, you developed a prototype, then you want to enhance its capability, and you want to scale up the entire scenario. Then you go for next project, or tie up with industry, or tie up with startup. Okay, then that pathways has to be mentioned. And also you have done though so much, you have spent 3 years of work in this field. Then you have to identify what is the scope for further work. You have done because of your limited time and budget and other things, this much I was able to do it. But if somebody is going to pursue, these are the scope for further work. Okay, and probably by end of the project, you may come to know, or after completion of the project, you come to know that, oh, I would have talked to that stakeholder or this industry or that government, whatever, whatever. That is quite possible. That possible users also you can mention about those things. Okay. Now we talked about the entire structure, the a broad framework of a proposal. We could talk about the minor and major pitfalls into the entire proposal writing. Unless otherwise you have a core research capabilities, it is not going to work out. Some people are talking, sir, we have submitted some 20 projects, nothing has come out, all the IIT fellows are getting all this thing. Okay. So now we had a discussion on this. Now you tell me, your proposal is meeting this criteria? If you say yes, definitely there is a problem in the system. Okay. And also, one thing you have to keep in mind, when the call for proposal gives, they define the broader themes. Okay. And your proposal should fit into that. Doesn't mean that you simply change the title and then you fit into anything actually. The content, everything has to be flow accordingly. Okay. Next slide. Yeah. For some people, you have to understand that, there are 8, 9 scientific departments. Some are doing, a type of open sky and blue sky research, funding. And some people are directed research, that means domain specific researches. Okay. So now, Ministry of Science and Technology is the ministry. We have the DST, DVT, DSIR, like that. These are all various departments. It's purely managed by the scientist. Okay, all secretaries are scientists. And it is for, irrespective of the domain, they have the, support, scientific support. Okay. Then we have specific to the earth sciences, we have one ministry. Environment and forest, then we have electronics, then these are all, DRDO and DOES, these are all very domain specific organizations. They have their own labs, they have their own research, they have their own operational systems, and very small amount they do take the help of academicians. You can, DOES gives, the, what is that basket? There is a scheme, and they will give you very clearly what is the required from the project, and then how much time they will give, and then how much money they will. Everything is defined. If you have expertise, you can map into that particular topics. MIT is specifically to electronics and information technology. DRDO, of course, it is a plethora of technology, but it is a directed research. So except MOST, all other are domain specific. So where these ministries or departments provide funds, but DST, DBT, and DSIR, open sky and anything, anywhere, everything they will be able to support, provided project is well written and properly defended. Before I get into this, one last point I would like to mention. Okay, you have written the proposal and then you uploaded. Now hard copies are not there, so you have to just uplink the proposal into site. Then what happens? This is what happens. The proposals first scrutinized at the concerning division level. For example, I will take example of DST. There are 24 divisions. I don't know how many schemes are there. Okay. And each division may be handling 1 or 2 schemes. One is cyclic, and another one is open the year, calls. When the proposals are received, and they will be scrutinized at the division level, they will see whether this proposal fit into the mandate of the call. Okay. If it is fitting, then generally it will be sent to peer review committees. As I told, there are each subject experts are available across the country, like you faculties only. They are not from the heaven. Okay, some of you may be reviewing the DST proposals. I don't know. Okay, so those proposals goes to a faculty or a researcher across the country, and they give their opinion first on the overall methodology, achievable objectives, and what is the newness in the proposal, and whether it is achievable or not within the given budget. Okay, whether asked budget is essentially required or not, and expected outcomes, is it possible? I mean, all this opinion, they have some 6-7 categories, so then they will give their opinion. In some cases, they may enhance the budget also. You may ask, some 60 lakhs, they say that, with this objective, with this methodology, with this equipment, it's not sufficient. Let us enhance the budget to, let us say, 90 lakhs. Okay, very rare case, but sometimes it happens. Okay, now those 5 people give their opinion, and they will give a rating between 1 and 10. And if some 3 people say more than 5, probably they will be called for presentation. Nowadays, small projects, they are not calling for presentation. But okay, if bigger projects, yes, there is a presentation. Who are the people in the committee? Again, same subject experts. Chairman is also from the academics. Okay, and DST representative is simply sitting there to facilitate the entire meeting to happen. They don't have any role in making decisions generally. Okay, now the the PI will be asked to make a presentation. Now generally people falter here. They will be given, let us say, 10 minutes and maybe 2 minutes for conclusion or 3 minutes for discussions. Now what I observed is, most of the time, see, you have 10 minutes. I don't think you can have more than 5 to 6 slides. But people do come with 50, 60 slides. They will start with their founder of the institute, whose great grandfather was a great man, and his grandson, he's created this institute, and the story goes for another 7 minutes or 8 minutes. Is not required. Okay, and then after 10 minutes, the people will say that enough is enough. Yeah, you come to your main point. No, sir, I'm just coming. You never come. So we fed up. Say that, okay, yeah, how to throw this fellow out. Then finally, when he comes to he has written, so entire proposal he projects onto the screen. He didn't made any slides at all, and start reading it. So obviously, if you give him the time, it will go for 1.5 hours. So when people don't have that kind of time, so what I suggest is, I don't know nowadays is still happening or not, I don't know. But generally, what you people should do is make a very clear 5 slides. Start with objectives. Don't tell all your stories behind the institute or the greatness of the founder or whatever it is. No, we don't require all those things. Okay, straight come to your background, objectives, and talk more about your methodology. What are the existing methodologies, why it failed, and how your methodology is going to succeed, and what you're expecting, and how it is going to take. It should not take more than 7 to 8 minutes. If you are not able to convince the expert within 5 to 7 minutes, you will never be able to convince even if you have given 24 hours. Okay. So, and then discussion, very pointedly. No, what do you call satisfying anyone. Say that this is what I am trying to do, this is how the methodology, then so. If you have any suggestion, tell me, I will modify. Okay. So, those type of clarity we should have. No out of way going and satisfying them. No, this I will modify, this I will do. I have done wrong, I have done this, okay, I would have taken this. No acceptance. Okay. So this is another important aspect. Then once a project is sanctioned, there are a number of issues, progress report, equipment purchasing, institutional problems, registrar is not allowing to procure, I will not get into all those things. Okay. So concentrate on the presentation is very important. Stick to the timings. If they have given 10 minutes, you stick to just dot. Switch on the time and then timer and then, finish it off. Even if you exceed, 30 seconds, your chances of rejecting is increasing. Okay. If you are not able to tell about your project in 10 minutes, okay, then is no point, in. So these are all other department. Important thing is, this Ministry of Mines nowadays is giving a lot of, the funding, both grant in aid and as well as, these things. So Ministry of Mines has got lot of interdisciplinary subject, either extraction, exploration, processing, waste management. Okay, huge amount of problems they are facing. Okay, now, unless otherwise, people, you may be mechanical engineer, there is a component where, you can contribute it to the, exploration. You may be chemist, but you can look into the, the processing side. Okay, there may be, civil or, GIS experts. They can look into the, the materials usage. There's a lot of, mining waste is getting dumped onto the ground, and it is getting into the environmental factors. Okay, so those things, the moment you say electrical fellow, I will say, Ministry of Mines, what I will do, I'm an electrical engineer. No, there is a huge component of, electrical things available in the Ministry of Mines. Look into their topics, look into their requirements, talk to the, the ISM Dhanbad, IIT Dhanbad now. Okay, and they're looking at a lot of things. Even hyperspectral image processing is being used. What type of mineral compositions are available? This is purely, physics. Okay, non-invasive technologies, imaging spectroscopy, quantification of these things. Okay, rare earth metals identification. Okay, so many things. Chemicals and fertilizers. Okay, again, huge amount of research is required for them to sustain the industries. Okay, next. So I will not spend much time on this. So fundamentally, the DST supports support for research. Okay, so if I have some interest in research and you have done some work and you want to pursue your spirits, and then we will support you. That's what DST says. And that is, various kinds of schemes are available, and then the call for proposals will come. So based on that, you respond and you compete. Okay, that's one kind is support to the research. Second is they also support increasing the the R&D infrastructure. That means for any good research, without infrastructure it will be difficult, at least in some subjects. Okay, so enhancing the R&D is a huge capex cost is involved in this. Then they thought, okay, now let us increase the R&D infra. So like FIST, then there are what is that? The other schemes mainly concentrating on enhancing R&D infrastructure. It is again, see, R&D infrastructure just like that they will not dump into any institute. Again, based on the researchers, their capability, what the work they have done it, and they will identify, yes, this kind of infrastructure is to be created in this institute so that all these researchers will get a boost. Then, of course, human resources development in terms of PhD, postdocs, and those type of things. Of course, we have the international S&T collaborations. Now, you people also can participate into the collaborative, research. These are all entirely different things altogether. And of course, policy coordination, regulation, these are some of the things that what DST does. Okay, so if you look into the kitty of DST, the main thing is support to the research and R&D infra increasement, and as well as HRD. International collaborations, of course, it is a type of a goodwill among all the countries who want to collaborate with us. Okay, next. So I categorize entire thing into three major drivers. One is individual driven research. So you as a researcher, you have proven track record of your research, and you want to enhance further. Then it is PI driven research. Okay, now you propose, and then you substantiate your proposal, and then you have to increase the spectrum of your research, and those kind of one particular item is available. Fundamentally, it is an individual expertise driven research. Okay. Most of us will fall into that category. Okay. Now, once you have a kind of expertise in one particular field, how you can fusion with other subjects and address a practical problem on the industry or government. That's where the multidisciplinary, interdisciplinary network-based cluster project comes into picture. That means it is not one subject or one research will fulfill the requirements. Okay. Now, various kinds of subjects has to come together, identify the research, map their expertise, and then address in a holistically a particular problem. Okay. Now, that's where the network project comes into the picture. Okay. And, I can take examples so many, but I don't think, limited time, So here, multidisciplinary is now the buzz thing. And, individually you are expert, but collectively you have to work on solving certain problems on the ground. Okay. And of course, directed research means, everything is defined. There are missions, national missions, where the DPR is written and saying that this mission will achieve so and so. Country is in that stage, but tomorrow after 5 years, we have to reach that stage. There are milestones and this is purely everything is. Only thing is if you have expertise, in contributing to that mission, you have to map those things. In individual research, you define your objectives. You define your spectrum of research. Whereas in directed research, already defined, then you have to map your component in those. These are the broadly, I will say, 3 categories. More or less, every ministry follows the same thing. All scientific ministry, what I'm talking about. Okay. So DST specifically, this is what, if you take all the 24 divisions, more or less, they fall into this category. General, it may be 50 lakhs. When you have JRF itself is costing around 12, 13 lakhs. This we have already discussed. Okay, publication patent, expected outcomes. These are all broadly we have to, cover. Next. And cluster projects. Yeah. This is the 5th item. Entire cluster works towards a common goal, objectives and outcomes. Okay. And tools, technology, solution, publication, patent, PhDs. Clusters are found, the verticals are defined. So this is, development of a cluster project itself takes a lot of time. Okay. And maybe in some other time, we can take 1 or 2 examples, how that cluster was developed, how the different subject. Let me tell you, no subject was let out. History was involved. Economics was involved. Political science was involved. GIS was involved. Point cloud data, what do you call cadastral, mapping was involved. Okay. So drones were involved in one particular project. Okay. There are around 80 PhD scholars, 30 projects, individual projects, all combined together, worked as a team to achieve a particular objective. That's a very beautiful network-based project. That itself requires 1.5 hour discussions. Next. Yeah, these are some of the things. These are all not real models. These are all scaled models. This is the project on Hampi. These are all terrestrial laser scanned, point cloud data, then wet to the CAD, then rendered, and then 3D printed, scaled models, maybe 3 feet or 4 feet models. So you can walk around them, and the dilapidated areas were digitally reconstructed and 3D printed. So how to create that missing part, that itself is a research. Anyway. So you can visualize how it was before destruction. Now whatever the existing is there, using that the earlier things were reconstructed digitally and 3D printed. Beautiful project. Even agamas were involved, historians are involved. Okay, everybody was involved and they came together. These are all different disciplines. A historian doesn't know how to talk to, how to interact with a technologist, because his language is different in the sense, his thinking is different and his thinking is different. So bringing all together, combining them, creating a framework, identifying their contributions, and everybody does their job, and collectively it becomes a solution to a particular problem. That is the cluster. Let's go next. So there are so many missions. I was involved in both NM-ICPS and NM quantum technology. To some extent, National Supercomputing Mission also. Initial days, I was there in the deep ocean, but later, geospatial technologies, almost I spent around 10 years. So what I mean to say is, there are missions, there are schemes, there are, projects. So where you want to connect yourself, and one is linked to other. When you are good at an individual researcher, always you can get connected to network. You are good at network, then always you can contribute to the missions. So one flow to not the other way. Okay. So there are so many new missions are coming. That like yesterday, what we talk about RDA, that is a scheme. These are all available. So there are specific calls that are given. You respond to that. So maybe I helped you in to some extent, in understanding all these things. And I will say, best of luck. Next. And under NM-ICPS, these are the some of the thematic areas. 25 hubs have been created, and each hub as the spoke. That means you have an expertise in AI and machine learning, and IIT Kharagpur is the hub. So there you have to get connected. So these are all the hubs. It's available in the DST website. You can go and see those things. Okay, and it's a huge mission, NM-ICPS. Even IIT Tirupati positioning and precision technologies. Okay, they're talking about GIS, then LTM survey, then also VLBI. So many advanced technologies. So fintech is IIT Bhilai. Okay, cobotics IIT Delhi. Human computer interaction, yes, this is also another focus area in RDI also. So more or less, all the emerging and futuristic technologies are listed out here, and they may be doing good work, I don't know. So you people, you can talk to them, or how we can chip into their no, remember that everything they will not be doing it. They have to align with other researchers across the country and support in terms of projects, and involve them as a spoke. That is the philosophy of the mission. Not that we have given to IIT Mandi that everything they will be doing, without talking to them. No, it's not that. Even there is a HRD, there is an infrastructure, everything is available in this. Anyway, so yeah, I think we came to the end of it.
Area which we want to explore. It is important to have the publication before we prepare the proposal, because that might be a new idea wherein we want to explore, and that's how a research proposal is drafted. But is it very much necessary to have papers published in that area also?
See, people do get good ideas. Okay. When you have some good idea or methodology, some preliminary work has to be done on that within your available resources. Okay. And you see whether that idea is really going to work or not. Okay. With the help of students, with the help of your, colleagues or wherever it is. Some preliminary work. With that preliminary work, if you are able to publish one or two papers, well and good. Or you say that I am getting good results, now I can go for a funding of the proposal. Okay. So, generally what people do is, in tier 1 institute, let me tell you, the faculty will identify a good research area, and you will bifurcate into small components. Okay. Now he has graduate students who are coming for this project. Okay. Use them to experiment that ideas. It's very small. A student can do it in 2-3 months. Okay. Now there are bunch of students who will work on the small components, and there is an MTech student who will coordinate the student and they will consolidate it. And there are some PhD scholars who will work all these graduates and MTech students. He will take it to the next level. Okay, so the idea is seeded by the faculty. Okay, and the students are doing the experimentations, coming out with their projects and as well as some learning also for them. Okay, and maybe 1 or 2 rounds of students, it will reach to a particular stage. You will get some results, some prototypes, some problems, whatever it is. Then what happens is, at that stage, whatever experiments you have done, it deserves a conference paper or a workshop paper. Okay, then further fine tuning of the results, it may fetch a good paper actually. So over the period of time, you will establish a type of a hold on that particular subject. Then you can go to a proposal and say that I have done these experiments. This is what results I am getting, preliminary results I am getting, and there's every chance that if I enhance this research, I may get a good results, and it is applicable to so and so people and so and so industry. And let me get the funding from you. Okay. So it's not that you fine morning you get an idea and day after tomorrow you just shooted a proposal to someone saying that it's a bright idea and nobody is funding. No, it may not happen unless otherwise a great idea which is going to shake the entire world. Okay.
Thank you so much, sir, for that inputs. Thank you.
Hello.
Yeah.
Hello, this is Dr. Gayatri Ambadkar from Pune. Sir, my question is, while writing the research proposal, there is a component salary for research assistant, JRF or SRF. So if
that is not research assistant. That is called project staff. Under that research assistant or JRF, you are building.
Okay. So it is mentioned that you have to give the salary according to the norms that are mentioned in the proposal. So
Correct.
when we prepare the budget, most of the time I observe that these component is becoming very high as compared to the other things like the
Correct.
equipments.
Yeah.
So in that case, is there chances that because the cost is getting high, the proposal will get rejected?
No, let it be. See, that's what the no problem is. Why you are worried about the cost? You know that you require a JRF in your project. Okay.
Yeah.
And why is required? You are able to defend it.
Yeah.
Okay. Then why do you bother about the cost? Whatever the UGC has given the JRF salaries or DST announcers, I don't know, whatever it is, 35 plus, HRA, whatever it is, that you build it 2 years JRF, third year it is, SRF. Okay.
Okay.
You build it.
No, most of the time, this total amount cost seems to be bigger as compared to the title of the research that has been mentioned here because of GRF.
No, but in that case, you have to defend, think whether JRF is required or not. When you feel that, it is absolutely required,
Okay.
then you should not worry about the cost. And also the same thing with the equipment also. If you feel that this particular equipment is absolutely essential for me to carry out this research, okay, then you can leave it to the expert committee and the government officials to look into that. When you are being called for the presentation, you say that put your foot down and say that yes, this is required. This research is important, and this is what is going to get, and this is the absolute minimum thing that I require it. So don't say that bigger amount, smaller amount, this amount, that amount. You have to technically substantiate your project. We have given 80 lakhs, 90 lakhs projects also.
Okay. Yes. Thank you. Thanks.
Hello, sir. Am I audible, sir?
Yeah, you are audible.
Sir, I just want to ask, based upon the total budget, if we take in the terms of percentage, how much percentage you should allocate for, let us say, contingency or equipment or the different budget heads? How wisely you should
The project
percentage
staff should be around 15 to 20%. Okay. Then
Yeah.
equipment, maybe another 15-20%. Contingencies and travel, around 5 lakhs. Huh?
Okay.
And maybe another 10% for the contingencies and those things. Travel anyway, it is 5%. Okay.
Okay.
Roughly.
Okay.
Yeah,
So
that is
based,
the general structure.
okay. So as
So
madam
if it is
earlier
an
to
experimental driven project, okay,
yeah, yeah.
and sometimes what happens, particularly in physics and chemistry, they will require a lot of chemicals and things, and then physics requires a lot of equipment and vagara vagara.
Yes.
So there the equipment cost may go up.
Correct.
So it depends upon the subject and field of research. Okay. So I'm giving you a type of a generalized view. It will vary case to case basis.
So, so it is based upon the justification given by the PI
Yes. Yes.
whether
Yes.
the project assist project JRF is required or as the madam earlier to me she asked. So even if the cost goes, the PI should be able to justify it.
Yes.
Am I correct, sir? Okay.
Correct. Correct.
Thank you.
Sir, good evening, sir.
Ah,
Sir, this
Dr.
is
Lavanya,
Dr.
tell me.
Sir, for the beginners, you gave such a nice explanation regarding how to write a research proposal and how to get a funded project, sir. It's a very informative session for me. Thanks for the valuable suggestions, sir.
Okay. So take these as the advisory points and establish your field of research and go for. I don't think even sky is the limit. Okay, but do systematically and concertedly. Yeah.
Sir, good evening, sir.
Sarita, Begumpet.
Myself, yes, sir. Myself, Dr. Sarita from Begumpet, sir.
Okay.
Really, sir, today I have the budget session by you was very informative, sir. Previously, I have applied for ICSSR project, but I failed at budget, sir. The committee also said your project was very good and they appreciated, but how to deal with the budget and how to convey them was one of the biggest tasks for me. But today's your information, your inputs are really helpful for me. Thank you so much, sir.
Okay. So once next time, if you get the proposal, at least you send me a thanks.
Sure, sir.
Murali, would you like to share anything about Research X Foundation or any message to all the participants?
Nothing more from my side. My only concern is, keep these things as a type of guidelines and evolve a good proposal. My suggestion is before, just giving it to the funding agencies or supporting agencies, probably, Dr. Nog, you can create a type of an expert committee within your organization.
Okay.
Get it reviewed and give them the feedback before those submit to the
Actual funding
organization.
agent.
Yeah.
Okay. Definitely. That's the plan. We'll do that.
Yeah.
So all the participants, thank you so much for taking Research Aids Foundation invitation and joining us. And we are very happy as a non-profit organization, Research Aids Foundation. We are very, very happy. Thank you, Murali ji. Without you, this session would not be this much wonderful. Thank you so much for taking time and sharing unconditionally this much expertise to the people. And all the participants, thank you so much. And we will be doing this kind of a lot of one-on-one mentoring also, and everyone know what Research Aids Foundation is, what we are trying to do. So thank you so much. If you have any questions, shoot us or maybe send an email, and we will be in touch and continue the. We wish you a very, very successful research year this year 2026 for all the participants, because majority of the people from research background. Thank you all.